viewers, Assalamu alaikum. Today we will discuss about free electron gas model. This is our second lecture on free electron gas model. So in this model we will discuss today the success and the failures of this model. Here there is two successes of this model. Their successes are derived functional form of Ohm's law and validities of Weidmann-Franz law, and the failures are electronic heat capacity and electronic paramagnetic susceptibility. So here in the success, Weidmann-Franz law, actually the ratio of thermal conductivity and electrical conductivity. This is ratio of thermal conductivity and electrical conductivity. And they are proportional to each other, and the constant is temperature T. So these two success they are the completely depends on the free electron gas model, and they are the great success of this free electron gas model. But there are some remarkable failures are here also for free electron gas model. So these are the failures of this model: electronic heat capacity and electronic paramagnetic susceptibility. And these two are very important property of metal, but they cannot describe properly by free electron gas model. That's why they are the failures of this model. So if we discuss today about failures of free electron gas model, we will start from here: electronic heat capacity. So if we want to describe this, at first we will start from assembly of electron in a metal box. Looks like this. So actually free electron model is basically assembly of free electron in a metal box. Electrons are moving around the nucleus, but it is moving inside this metal box. If we apply heat on this metal, so what will happen? It will absorb heat, and each electron absorb heat. It will increase the temperature T. Then each electron will have absorbed energy also. So the absorbed energy is 3/2 kBT. Kb is Boltzmann constant, we know. So that is equipartition energy law. If we consider now 1 Gumbel of Avogadro number, and we will multiply by 1 Gumbel of Avogadro number with this, then we will get the total energy of this absorption of this metal box. So this is 1 Gumbel of Avogadro number, and this is equal to total energy of this metal box for free electron. Now we know heat capacity C equals to dE by dt. That means how much energy is required to change 1 dt temperature. So this is the molar specific heat which can define by 1 mole. So if we put this value E from here, so we get for free electron theory 3/2 NaKB equals to 3/2 R. Because this is a molar gas, that's why NaKB means R. So R is generally 2 calorie, so the value of C means 3 calorie. Okay, this value is very high compared to experimental value, and we get this value by the result of theoretical process, but the experimental value is not matched with this value. So heat capacity basically has two contribution. One is lattice vibration, and another is electronic contribution. So for for electronic contribution, total molar heat capacity actually 3R plus 3 by 2 R. But it is seen that electronic contribution almost 50%. So contribution electron of matter is very small. It is around 1 by 100 into 3 by 2 R. And it is experimental value. So these are the remarkable failure of free electron gas model. Okay. Now for the second failure, if we consider, then at first we have to say that there are 4 types of magnetic property on the terms of susceptibility. One is diamagnetic, second one is paramagnetic, diamagnetism, second one is paramagnetism, third one is ferromagnetism, fourth one is ferrimagnetism, magnetism. So we can explain on the term of susceptibility of this for magnetism. So what is susceptibility? What is susceptibility? Susceptibility is the ratio of magnetic moment of magnetization and magnetic field. So this is defined by chi, and this is magnetic moment of magnetization, and this is magnetic field. So magnetic moment, what is magnetic moment? If the electrons are moving around the nucleus within this metal box, so there is we can find magnetic moment also. We have already told about this matter in the previous lesson. So magnetic moment of each atom, they align to magnetic field direction. Magnetic moment per unit volume is called magnetization. So magnetization means magnetic moment per unit volume. So at this magnetic field, what are the magnetization? This is susceptibility. So if we take 1 gram of metal, so we can write this susceptibility, molar susceptibility, chi m equals to m by h. It has 1 gram of metal. This metal have free electrons, so Avogadro number of free electron will be there. So one can find out molar susceptibility, chi m equals to also, sorry, I will write here, chi m equals to n a mu b square divided by 3 kBT. So consider the free electron gas model to take 1 gram metal of Avogadro number. In this case, is expression for molar susceptibility mu depends on mu b actually. So mu b means Bohr magneton. Mu b means Bohr magneton. This is universal constant, and the value of this constant, the value of mu b is 9.27 into 10 to the power minus 24 joule per Tesla. This is joule. So from where we get this value? Obviously on the depends on electronic Bohr magneton equation. So the Bohr magneton equation, mu b equals to E h cut by 2me, which depends on electronic charge. So this is electronic charge, this is Planck constant, this is mass of electron. If we put the value of those parameters, then we will get this value of Bohr magneton. When H in a ground state, hydrogen. When hydrogen in a ground state, electron in 1s orbital. So for hydrogen electron, the electronic configuration like this electronic structure This is the nucleus of hydrogen, and this is the valence electron of this hydrogen atom. So this valence electron is moving around the nucleus of this hydrogen atom. Then we can find out magnetic moment also from here. If it is moving, then there is electricity flowing. For the electricity flowing, we can say there is magnetic moment also induced. So by the result of theoretical process of free electron gas model, we get molar susceptibility chi m is proportional, inversely proportional 1 by T. So, but the experimentally for non-ferromagnetic material, generally chi m is independent. For non-ferromagnetic material, non-ferromagnetic material or metal, this molar susceptibility is independent on temperature T. So it's a big failure of free electron gas model on the paramagnetic susceptibility. So today up to this, these are the failures of free electron gas model. We will learn next more about free electron gas model. If you like this video, then please subscribe. Me Nilofer Tanisha from Uttar University in the Department of Physics. Thank you very much. Assalamu alaikum.